Greetings, everyone, and welcome to today's webinar on switch troubleshooting. So today we are going to be entering a few escape rooms, and our goal is to exit the escape room unharmed. That's our goal today. And it's going to be all about switching. So we're not going to deal with routing, folks. We're going to be dealing with switching. So it's great to have every one of you here for today's webinar. And we're going to be spending our time utilizing this topology whereby we have our access layer down here. We have our distribution layer here. And this is the core of our environment. So access layer, distribution layer, and core. And I'm going to present to you a few different scenarios. And the scenarios are the escape rooms. And we are going to solve whatever that problem is together as a group. What does that mean? It means you need to log into this chat area. That way there you can play along and you can help me escape. Today's Friday. I really don't want to be here over the weekend stuck in these escape rooms. I need your help, folks, to get out so I can enjoy my weekend. The golf courses are open now, and I get to go play a round of golf or two this weekend. So I need help. I need help. But before we actually dive into our first escape room, I want to take this opportunity to have a brainstorming session with each and every single one of you folks. So what am I looking for here? I'm looking for everyone to chat in to this chat tool, different technologies, services, features, functions that may exist in this part, folks, this part of the network. So in our layer 2 environment. So what can we find down here, folks? Go, chat in. All right, spanning tree protocol, absolutely. BPDU guard, absolutely. VTP, VLANs, MAC addresses, ether channels, trunks, absolutely. CDP, DTP, VTP, even, yes, access control lists. That's right. We can have access control lists on our SVIs, LLDP, trunk filtering. We'll have our different interfaces, absolutely. Link aggregation or ether channel bundling. So typically our IP tables are going to be up in this area here, the IP tables. But we'll have MAC address tables down here. MAC address tables down in this part of our network. And therefore MAC addresses that we'll be dealing with. And let's not forget about first hop redundancy protocols. Because we'd run first hop redundancy protocols between those distribution layer devices, so that way there we can have redundant default gateways. ARP, QoS, great job, folks. Voice over IP, amazing. So as you can see, this, oh, what about speed and duplex? Forgot about that. Speed and duplex mismatches. So as you can see, there is so much going on in this part of our network that it's imperative that we have a solid understanding of all those different services, features, functions we have in our environment, so that way there we can troubleshoot more efficiently and more effectively. But also, it's to make sure that we are implementing these services as best as we possibly can. Because just because your network is working doesn't mean it's working as it should be working. And we're going to have a couple of those examples here today as escape rooms. Even though our clients are not having any issues, our network's not behaving like it should. SVIs, that's right, SVIs as well, another technology that is going to come into play here today as well. So folks, let's dive into our very first escape room. And here is the scenario. PC6 cannot reach the IP address of 192.0.2.1. It's that simple. They cannot reach it. Now, where is that? That's out on the internet, folks. That's where that is, the World Wide Web. So we won't have access to 192.0.2.1, but they're complaining they can't reach it. All right. So we need to now figure out what is going on here. Any suggestions? What should we do first, folks, when it comes to troubleshooting? What should you always do? Go ahead, chat in. Ooh, good. I see some pings, trace routes, verify addressing information. All right, let's go ahead and start doing that now. So we're going to go over to PC6. Now, just so you understand what I've done here, PC6 is a router that I've turned into an end station. So even though you can see a router type prompt here or a switch type prompt here, all I did was take a router, plug it in, and I turned it into an end station by turning off routing on it. So if I type in right now, show IP route on this router, folks, you can see this router is not doing any type of routing whatsoever because this is not your routing table. Okay, this is not your normal routing table. But we can see here that we have our default gateway here. So the default gateway for PC6 is 10.0.30.254. And the IP address of PC6, so show interface or IP interface I'll put in here, is going to be fast Ethernet 0/0/0. All right, so there's the IP address, 10.0.30.5, and we have our default gateway. So let's be very mindful here that PC6 will never be the issue. That's right. So it's always going to have an IP address. It's always going to have its subnet mask. It's always going to have its default gateway. But the problem can exist anywhere from here, folks, all the way up to here. Anywhere in there. All right. So with that said, many of you said, let's go ahead first and do what? Ping. And that's always something you should do. If connectivity doesn't exist, let's ping that destination and see, is this truthful or not? And so we can see that it's not working. These periods here indicate that the destination is not reachable. We can't get there. All right. So now, what's the next thing we should consider? So we can do a trace route to see if we're getting very far. We can try that. Let's give that a try. And there's no response here whatsoever. All right. So we can't reach the destination with a ping, and the trace route is not working either. So I really like what I'm seeing next. And what is that? Let me abort this right now. Control-Shift-6. And that is ping your default gateway. That's a really, really great idea right now, folks. Why is that? Why is that? It's because if you can't reach your default gateway, then you have confirmed there is more than likely an issue right in here, this area right here. But if you can get to your default gateway, well then there's no problem here. And as a result, you should be focusing where? Elsewhere in the network, like in the core, with your routing protocols. Or maybe it's routed ports here, or the routing table's not correct here, routing protocol's not set up. But if you can get to that default gateway, layer 2 is working. Now, it may not be working properly, but it is working. You can get to your default gateway. So I like that. Because now if we ping that IP address, our default gateway, if we can get to it, then we can shift our focus away from layer 2 and start looking elsewhere in our environment. But we'll see here that I cannot reach my default gateway in this case. Now, just so you're aware, based on the coloring scheme I have set up here, notice that VLAN 30 is the red VLAN. There's the IP addressing space. Notice it's colored red here. So PC5 right here, which we're not going to deal with today. But PC6 definitely is part of VLAN 30 based on my topology. And if we pay very close attention here, you'll see that DSW2 is supposed to be the default gateway for VLAN 30. And we are using HSRP in this topology. So HSRP is supposed to be set up with DSW2 being the active forwarder for VLAN 30. So with that in mind, our traffic under normal conditions should be flowing something like this. It should be, right? But right now, it's not flowing at all according to our pings. All right, so what should we do next now, folks? What should we do next? All right, so even if I ping 8888 now, it's not going to make a difference because if I can't get to my default gateway, then I definitely can't get to 8888. All right, wow, a lot of great information coming in. All right, definitely it would not be NAT because NAT would be something we would be doing on the edge router connected to the internet. And so it'd be something at our edge layer that's connected to the core somewhere else. So it definitely would not be NAT in this case. Because NAT is a layer 3 technology, not a layer 2. Check interfaces and neighbors. Okay, I like that. You know, it's really great if we have a troubleshooting plan, folks, that takes us on an adventure from that end station towards the default gateway now. That is something you should always consider when you're troubleshooting. If you have an approach in place that you always follow, then you're going to be successful a lot quicker than you normally would be. So you can, from a troubleshooting standpoint, work on the technologies going this way. Or if you want to start up here and work your way down, that's perfectly fine as well. But whenever you're troubleshooting and you're trying to escape a scenario in your environment, having a plan in place that you do every single time is going to make you as efficient and effective as you can possibly be. All right, so with that in mind, folks, if we leave this PC and we come up here, what are we connected to right here? We're connected to a port. We're connected to a port. Wouldn't it be good to see if this port's even up and running? Would that be a good idea? I think so. So let's go there on ASW2. So over on ASW2, what command can we use? Well, we know it's gigabit 1/0/13, and there's a lot of commands we can use to verify that port, if it's working, if it's connected. So we could use the command show interfaces, gigabit Ethernet 1/0/31. And let's see what it tells us. It tells us that we are connected to PC6. Great. But what here, folks, tells me that I have a connection right now that is working, that is operational between ASW2 and PC number 6. What should I be looking for here that is going to help me? Excellent. Absolutely. It's these two values right here. Up, up. That's the two values. So we know we are up at what? Layer 1? We are up at layer 2. That's what that tells us. We're up at layer 1. We're up at layer 2. I have a physical connection and I can successfully speak or build frames, Ethernet frames with you, encapsulation ARPA, Ethernet. I can build those frames and I understand them. We understand each other. So essentially we're speaking the same language and we can actually hear each other. Layer 1 of the OSI model, layer 2. So we now know there's not an issue right now between PC6 and the actual port. Now, does that 100% confirm for us that no other tool or service that could be on this port has hurt us? Meaning, for example, something like BPDU guard or port security. Folks, can we right now eliminate port security and BPDU guard as being issues? Right? Carlos says yes. I like where Carlo and Joe and Will, I really do, even Greg. Yes, you're right, we can. Why? Because typically, if you have BPDU guard that has been triggered, or port security that has been triggered, normally what would happen to your interface if you were using the default methods of both of those particular protocols? Okay, the interface would go what we call air disabled. And when your port goes air disabled, it actually goes down. You would see down here. Down. So that's good right now. But it doesn't necessarily mean that port security being in what is called restrict mode is not blocking me right now, because maybe we do have a port security violation. So port security in shutdown mode would cause this to go down, but port security in restrict mode would not. So we should check port security here just to see if it's running, to be on the safe side. And that's a good thing to do, right? Now, you would know in your environment whether you have it running or not. In this case, I'm not sure. So let's do it. Show port security. There we go. And you'll see here, there's no interfaces right now configured for port security. So we can rule that out as well. We can rule that out. But another way that you can check if a port is air disabled, folks, is use show interfaces status. So let's scroll down to gigabit 1/0/31. And what we're going to see here is that in this case, 1031 connected to PC6, it says connected. If these were air disabled, folks, it would actually say here, air disabled. That's what it would say. That's exactly what it would say. And then you can always type in show interface status air disabled, and it'll tell you the exact reason why. But since we have no air disabled interfaces here, it's not going to show me any output. All right. So what do we see here? All right, great. So some of you are, while you're here, you're now making some connections. All right, so it says we're supposed to be in VLAN 30. All right, so it says VLAN 30, gigabit 1/0/31. That matches our topology, matches our diagram. All right, what about speed and duplex? Okay, so it's auto full, auto 100. Let me ask you this. If we had what is called a speed mismatch, folks, a speed mismatch, what would happen in the interface if you had a speed mismatch? Yeah, it would go down, right? Down. So we're not down. We're up right now. So we know we don't have a speed mismatch. Right now, if we have a duplex mismatch, it would mean we have slow connectivity, not no connectivity. And right now we have no connectivity, so we can rule out the duplex mismatch as well. Excellent. All right, so far so good. So where do we go next now, folks? What should we confirm next? Check VLAN. Show interface trunk. Show interface trunk. Running config. I forgot to specify the rules of the escape room. The rules of the escape room state you are not permitted to use any logs or syslog messages or the running config. Oh, all right. We're banned from using those. Okay, so is it in the right VLAN? Yes, we've already confirmed that. So I see a lot of people focused on things like the trunk. So the trunk's here and checking the VLAN. So let's do that. Show interfaces trunk and see what we find here. All right, so we can see gig 45, 46, 47, 48. They're all trunks. It says 45, 46, 47, and 48. All VLANs are allowed on the trunk. And then it says here, VLANs allowed and active in management domain. All right. So What is the actual problem? So no VLAN 30 is being passed over the trunk. That is correct. That is correct. So I see a lot of people indicating that VLAN 30 has been pruned off the trunk link. VLAN 30 is missing. Right. How can we double check that? Let's look at show interfaces, gigabit 1/0/47. So we'll take a look at just one of these trunk links that don't show VLAN 30. Let's type in the switch port command right now. When I look at this output, folks, I don't see any indication of any VLANs not being allowed on the trunk. So I'm going to break our escape room rule right now just to show you. We're going to go show run interface gigabit 1/0/45 just to show you. Do you see any pruning command there whatsoever? Any filtering command there whatsoever? We don't, okay? If we did have filtering in place, we would see that in the other output. So let's now look at what all of you, the other folks, have been saying. Let's check to see if the VLAN even exists. Why? You will not forward VLANs or traffic for any VLAN if the VLAN doesn't exist. So this output right here is indicating two different things. It's telling us which VLANs are actually allowed, which is all by default, but only allowed if they're active in the management domain. Oh, yes, that's right. Meaning that we also have to check to see if it's in the database. The database. And we can do that by typing in show VLAN brief. Absolutely. You're all correct on that one. Show VLAN brief. And as you can see, VLAN 30 is... Maybe it's at the bottom? No? Oh, boy. It's gone. There you go, folks. So how do we correct this problem now? Oh, I want to show you another thing, though. Watch this. Let's type in show interfaces gigabit Ethernet 1/0/31 switch port. Take a peek at this, folks. This command on gigabit 1/0/31. Look what it says. Look at that keyword. This is a big indicator here. What does that mean? VLAN does not exist, even though you are a member of that VLAN. VLAN does not exist, even though you're a member of that VLAN. And as Bo has indicated, that VLAN was deleted. Absolutely. So let's add the VLAN back in. We are not using VTP in this case. So if I type in show VTP status, you'll see we are running in transparent mode. And if we go over to somebody like DSW1 and we type in show VLAN brief, you'll see DSW1 has VLAN 30. So DSW1 has it. Show VLAN brief. DSW2 has it. So my distribution layer switches have it. ASW1 has it. So for some reason, somebody deleted, I don't know who that could be, definitely wasn't me, deleted VLAN 30 off of ASW2. So now that we add the VLAN back in, folks, let's take a look. Show VLAN brief. And we'll now see that VLAN 30 appears with all of the ports that are a member of it. So gigabit 1/0/31 is listed there now. And then if we now go to show interfaces trunk output, we're going to see that the VLAN is now allowed because it's active in the management domain. And if we look at the output of show interfaces gigabit 1/0/31 switch port, we'll see that the VLAN name is actually there now. And then we'd absolutely want to do what? Copy run start in order to save the changes we have made. So let's now, we're not done. Let's just make sure we can escape now. So first we'll ping the default gateway. Yay, all right, that worked. And now let's go ahead and ping the actual destination, and that works as well. So folks, congratulations, well done. You have gotten me out of the escape room number 1, but unfortunately when I leave escape room number 1, what happens? I enter escape room number 2. Oh, that's right. So one door leads to another. It's multiple escape rooms back to back to back. So here, this is going to be interesting. And why is this interesting? Because PC6, or any PCs, nobody's complaining right now. Everybody has the connectivity that they need right now. So what does that mean? Well, it means that we have been experiencing some degraded performance right now. Our monitoring stations, monitoring systems have notified us that this part of our network is just not behaving as it should. And so we do a little bit of further investigation, and what we find out is that traffic, for example, leaves PC6, goes to ASW2, and then what happens? It goes to DSW1. DSW1 then sends it across the trunks to DSW2 because DSW2 is the default gateway. It's the active forwarder. And then it gets sent out to the internet. So the question here is this okay? Is this acceptable? Is this really acceptable? The answer to that is no. It's not, folks. And it is possible that in your own environment, you could have traffic flowing like this because of protocols and services in layer 2 that haven't been configured properly. You see, one of the things that I stress in my CCNA class is that you learn all of the different services, not as individual entities, but holistically. You really need to understand how they affect each other. Because in this case, the protocols that we have running, the services we have running, they're actually misconfigured. And as a result of that, I have caused this inappropriate traffic flow. And as a result, I am now in this escape room that I need to get out of. So help me out, folks. As you can see, if I ping right now 192.0.2.1, it works perfectly fine. If I ping my default gateway, it works perfectly fine. If we trace route, you can see it's going through DSW2. But my monitoring systems and solutions I have in place are telling me the traffic is flowing this way. So first things first, folks. How can I verify that the traffic is flowing this way? How could we do that? Let's use PC6 as our starting point, and let's confirm this first. Because I want to show you how you can do follow the path here for confirmation. What can we use to confirm? Yeah, Brian, that was your question. Excellent. Not trace route. No, because look, we just did a trace route. And the trace route only tells me the routers we go through. It doesn't tell me the switches we go through. No, right? It doesn't tell me the switches we go through, just routers. All right, so we definitely could use CDP. Absolutely. But I need something else. There it is. Absolutely. Great answer. MAC address table. That's what we got to do. MAC address table. So PC2, let's confirm that it's actually connected. Show interface status. Is the interface connected? Got to hit the right button. So got to get down to 31 here. So 31 connected to PC6. It is connected. VLAN 30, full 100. All right, so we know we have connectivity there, right? The thing is what I want to know now is where are we going? And so we have to think about the fundamentals now of our frame. So we know the frame's coming in this interface. The frame's coming in this interface right here. But the question now is, what is the source and destination MAC address of that frame, folks? What is the source and destination MAC address? So the default gateway's DSW2, that's our default gateway. So good, yeah. So our destination MAC is going to be the default gateway in that frame. And then our source MAC is going to be PC6's MAC. That's what it's going to be. So when we're forwarding frames, folks, do we care about the source MAC address when we're forwarding a frame through our switches? No. What do we care about? We care about the destination MAC address. So if we go to PC6 right now, the frame that PC6 would have created, folks, is in relation to what IP address? So let's rephrase that. The destination MAC address in the frame is going to be related to whose IP address? Exactly, default gateway. So what is our default gateway IP address? 10.0.30.254. And remember, this is a router, so I'm going to use show ARP to get the MAC address here. And although there's other IP addresses, we're not doing any routing at all on this device. But you'll see here 10.0.30.254. There's the MAC address. So what we're going to do is we're just going to focus on AC1E. So AC1E is going to be our focus as we go through that MAC address table. So let's go to ASW2 now. So what are we looking for? We're looking for in our MAC address table, show MAC address table, dynamic, because these would be dynamically learned, so we'll have less output here. Where's AC1E? AC1E. Okay, there it is. All right, so notice that it's using gigabit 1/0/45. So it is pushing it this way, the frame. So PC1 sends it to ASW2. ASW2 takes that frame and sends it to DSW1. Now, if we go to DSW1, what are we going to see here? If we type in show MAC address table dynamic, we're going to see that AC1E is pointing towards gigabit 1/0/17. So folks, even though this is also a router, it's a multi-layer switch, even though it's also a router in this topology, and even though it is the standby default gateway, in case this default gateway fails, notice how, because it's not responsible right now for being the default gateway because DSW2 is responsible, because it's the active forwarder, DSW1 forwards it to DSW2 using layer 2 MAC address. So no routing, even though it's a router, and it would probably know how to get to the destination packet, the destination IP of the packet, so the server, whoever we're trying to reach, the fact is, that's not its job right now. Its job is to get it to the default gateway through layer 2. And that's why we're having this problem. So now the question is, what could cause this problem? What could cause us to have traffic going the wrong way? See, I don't want this. I want my traffic going from PC6 straight out this way, folks. That's what I want. I do not want this. All right, so what are we going to do? Power it off? No, we're not going to power it off. You know, that would work, though. That would work. Good one. All right, let's take a look at this. Show MAC address. Let's take a look at that. Primary. Okay, so I see a lot of people saying spanning tree protocol. So I agree. Spanning tree protocol could be the reason here. What else could be the reason, folks? What else could be the reason? Brian says, can we find out who's actually standby and actually who's active? Sure, why not? So I'm going to type in show standby for VLAN 30. And you'll see I am standby. And if we go over to DSW2, I can type in show standby for VLAN 30. And we'll see that we are active. All right, so if it's not spanning tree protocol, folks, could it be because these interfaces are actually down? Yep, one of you said interfaces aren't working. So if these interfaces are down, then we could absolutely be taking the other way. Absolutely. So let's go to ASW2, show interfaces status. And we can see in our output for gigabit, 47, 48. All right, they're not down, and they're configured as trunk ports, so we're good there. What if they weren't configured as trunk ports, folks? What if they were configured as access ports in VLAN 1? Could that also cause the problem? Absolutely. Sure. So if these ports are down, so 47, 48, if they're down, or these ports are down, then the traffic's going to have to go that way. If they are misconfigured and they're not trunk ports that support traffic for VLAN 30, then the traffic's going to have to go that way. So those are different things we'd have to check. But a lot of you were jumping on spanning tree protocol right away. A lot of you. So what would cause, with spanning tree protocol, the traffic to flow this way? What is causing that? Brian, who's that? BVD, should DSW1 learn about PC6 on gig 2324? So PC6 is this one here. It's learned it on 23. Yeah. So it's learned it on 23. Good. Yeah, a lot of people are saying, let's start off with the root bridge. Let's just start with the root bridge. Why? Because with spanning tree protocol, folks, if you weren't aware of this, when you learn about spanning tree protocol from someone who doesn't take the extra time to tell you that spanning tree protocol is a lot more than just a loop prevention mechanism, okay? So many of you have learned that that is what spanning tree protocol is, loop prevention mechanism. I have to have it running, so that way there, if I end up with a layer 2 loop, I don't end up with broadcast storms, etc., etc. Yes, but what spanning tree protocol also does is it controls the forwarding path of your layer 2 traffic through your network. You know how routing protocols control how your traffic is routed? Well, spanning tree protocol is the protocol that controls how your frames are forwarded. So if you don't set up spanning tree protocol properly, you end up in situations like this. And this is absolutely a spanning tree problem. So many of you say, let's check out the root bridge. So if I want, folks, with spanning tree protocol, if I want my traffic to flow this way, where should the root bridge be? Brian says, if there's no redundant links between switches, is spanning tree needed? Well, if you have zero redundancy whatsoever, spanning tree at that point is not needed. But you don't shut it off. Because what happens if all of a sudden you do end up with it? As soon as that happens, you need spanning tree protocol. So you just leave it running. And spanning tree protocol is smart enough to know whether it needs to do something or not. It's been designed that way. So in this case, for example, as soon as you have redundant distribution layer switches with a layer 2 trunk, and you put one port here, as soon as you have a triangle, there's your loop. Whether I only have one link between all the switches or 8 links between all the switches, I have a loop as soon as I build a triangle. And then in this case, I have way more loops because of all of the triangles and figure eights that I have in this scenario. So a spanning tree is needed no matter what. You always want it on to protect yourself. And it's on by default, which is fantastic. All right, so everybody's saying DSW2 should be my root bridge. Absolutely, I agree with that. This is where you want your root bridge to be. Because once this becomes the root bridge, then we're going to see this topology adjust itself. Right now, if we analyze ASW2 for VLAN 30, so show spanning tree for VLAN 30, you'll see here that spanning tree is pointing us out gig 45, and that's why the MAC address table has the default gateway associated with 45, because spanning tree protocol is controlling that path. That's what's happening. So then you go to DSW2, show spanning tree for VLAN 30, and again, we're going to see that our gigabit 1/0/17 is pointing towards DSW1 right now. Like that, because it's a designated port. So that's why we're getting that traffic flow right now, because ASW2 is forcing it this way, and then when DSW1 makes its forwarding decision, it sends it here. So with that in mind, how do we change our root bridge now? And you'll see it even says here, we are the root bridge. So if I now move it to DSW2, configure terminal, spanning tree, VLAN 30, whoops, there you go. We'll set the priority to what, folks? 0? Lowest possible value in this case. Gives me the best chance of becoming the root bridge. Do show spanning tree for VLAN 30. And what are we going to see here? We're going to see that we are now the root bridge. So with that in mind, let's take a look at ASW2 and see if this has changed. Let's see if this has changed. And it has. Look at 47 now. And so therefore, if we look at our MAC address table, we should see the default gateway is now reachable out 47. Therefore, we've accomplished our objective. We have escaped successfully, folks, in this particular case. So we open the door, we walk out, and what happens? We end up in another escape room. Oh, no, yes, we do. All right, folks. This particular scenario, just double checking here. What I got to just making on that device. We're good. Made the adjustments. Yes, I am happy with those changes. Roll back. And we're good. All right. So here's my new room that I'm in. That's just mind-boggling. We have the exact same situation. We have these monitoring and reporting systems that are telling us that our traffic is flowing like this again, folks. Traffic is flowing like this again. So I want to see how quick we can come to this conclusion now. So obviously, it's not going to be a missing VLAN. Because if you can successfully ping, you can successfully trace, that means the devices you're trying to go through have the VLAN that they need. Especially if we're getting this through this one and we're hitting up this one, we have successfully hit the VLAN. So let's do our ping. We know that we can get to the default gateway. The thing is that nobody's complaining. It strictly comes down to these monitoring solutions and software we have in place that's telling us that the performance is not as it needs to be. Traffic is not following the right path, and we figured out that it's going this way. Now, again, we check the MAC address table, we'd look at the flow of traffic and all of that, and we would see that it's taking us along that path. So, folks, consider this. It's not going to be spanning tree protocol again, obviously. But do you remember what we talked about in our previous discussion of what things could possibly be the problem? Excellent. Yes, perfect. So as you can see, folks, as you evolve in your troubleshooting skills and you take that approach of making sure that when you troubleshoot, you learn and learn and learn and you analyze, it could be this, it could be that, and you make notes of that, then the next time something happens, you already have that information and you know, let's go check this, let's go check that, let's go check this. So, as you said, let's go check our ports. So if we type in here, show interfaces status, just to make sure, are they up? Are they operational? Are they connected? Because if they're not, we're going to be flowing the other way. And we're looking for what again? We're looking for 47 and 48 in this particular scenario. Okay, it says they're connected. It says they're chunk ports, speed, duplex, everything looks good there. All right, anything else, folks? What should we look at next? All right, show interfaces trunk. Let's do that. Why? Because remember, we need to be able to pass traffic across those ports. Let's take a look though. Let's say you decided, hey, let's check if it's spanning tree protocol again. All right, let's go do that. Notice we are the root bridge. So even though we are the root bridge this time, oh wait, we're not, are we? No, that's DSW1. DSW2, that's what we want to look at. So go to DSW2, are we the root bridge? What are we going to see? We're going to see that we are the root bridge. So that's the root bridge. That's our secondary root bridge if we need. So even though we're going this way, some other technology is causing spanning tree to make this decision. So if we go to ASW2, before we type in show interfaces trunk, show span for VLAN 30, we will see it's forcing us to go which way? It's forcing us to go this way. But what is missing in this output, folks? What is spanning tree telling us here before I type in show interfaces trunk? What is it telling us? Don't worry about the cost of the port. That's okay. The cost is fine. Right now, yeah. Is 47 and 48 there? Look at that. They're missing. That's it. The two ports that we are concerned about are not even there, which means those two ports are not participating in VLAN 30. So show interfaces trunk. Notice here it says VLANs allowed on trunk. I think 30's missing. And there you go. So this is a prime example. Notice how when you have a filter list in, folks, think back to Escape Room 1 when we were talking about the filter. Notice when you do have a filter list, it modifies this right here. The very first part. Very first part. So now what do? Configure terminal. Interface range, gigabit Ethernet, 1/0/47/48. And then what do? Switch port, trunk, allowed, VLAN, add, 30. Whew. All right, double check, do show interfaces trunk. And you'll see they're all allowed now in our case. So 30 is allowed on those two ports, which means it should now have done what? It should now have modified spanning tree protocol because those ports exist now. Root port means we're pointing this way. So now we're going this way, which means once we get to DSW1, or DSW2, pardon me, away we go. So we've successfully solved that. All right, so we are out of this escape room now. And I'm looking at the time. We have time for one more. So I'm entering escape room number 4 now, folks. And let me make my quick modification here based on my notes. All right, here we go. Let's make sure I don't mess this up. Configure, replace, and then we'll type in flash because I'm trying to pull a configuration file I have, folks. So that's what I'm doing right now in the background. Pulling that configuration file. That's the one I want. Yes, please do it. And then I have to do 2 more things for this one to work. Yes, I love breaking things. I really do. Russ Long's here in the chat area. As you can see, he's a fellow colleague of mine. Russ knows I love to break things and make him fix them. Just ask him about it. All right, so let me go into this mode now. I'm going to do this, and then one last thing. I just got to be patient now. Just have to be patient. This one takes a little longer to set up. Yeah, so folks, okay, so there we go. So as you evolve in your career, the thing I want you to just realize is that you are going to have to learn from your environment, learn from your mistakes, but you have to know the fundamentals. If you know the fundamentals, then you can accurately learn from your mistakes. But if you struggle with the fundamentals on how everything works together, it's hard to learn from your mistakes because you don't understand the why. Why did it happen? So going forward, folks, I encourage you to be one of those people that ask why. Why? Anytime something happens in your environment, why? Why? Seek out the answer to that why, and that's going to make you or take you to the next level in your career. So Escape Room 4, folks, guess what? Traffic is going from PC6 through DSW1 to the core. What? Yes. And it's not supposed to be. This is our fallback, failback, secondary path we want to take if DSW2 is not available. See, we want our traffic to go this way under normal scenarios. And we only want it to go this way in a failure scenario. So I need to figure out why this is happening. Why is this happening now and not the normal way that we need traffic flowing? Question come in. Can an access port have an effect on spanning tree decisions? Only if that access port has been plugged into another switch port on another switch, then yes, it could. But if that access port is going straight down to a PC, a phone, an access point, a printer, things like that, then no. Then no. Not to that degree. Right? But absolutely, if that access port gets plugged into another access port or some other port on another switch, then yes, that could cause spanning tree to do its job. All right, so question, people are saying, did DSW2 fail? I hope not. Let me just take this off the screen momentarily because I want to make sure that everything is correct. I just have this bad feeling that a syslog message is going to pop up on me for some reason. And nope, we're good. All right, so let's bring it back up. There we go. All right, so no syslog message that would give away what's wrong. So everybody's wondering if DSW2 is up and running. So let's type in. There for a second, I thought it was down, folks. Show VLAN. Let's just say show VLAN brief just for a second. Okay, so I'm getting results from this. Show interfaces status. Let's check that out just to make sure. So we got our connected interfaces, 13, 14 routed ports. We've got some trunk links there. All right, so it's up and running. It is not busted. It's not busted in this case. It's not down. It's online. All right, so check DSW2. So let me ask you this, folks. If we have redundant default gateways in our environments, then one of them, especially with HSRP or if you're using VRP, is going to be responsible as being the active forwarder at any given time. And we can see that the traffic's going from here to here, obviously, and we can double check it in our environment. So if we go to ASW2, show MAC address table, dynamic, what are we going to see? We're going to see that our default gateway, which is AC1E, is pointing 147. Oh, wait. What? Oh, this is even worse than I thought, folks. Look at this. This is even worse than I thought. Or maybe not. So always verify. So it's actually going this way. All right, let's go to DSW2. Maybe there is no problem here. And then we have... Oh, yeah, look at that. It's actually going this way, folks. Oh, this is even worse than I thought. Look at that. How? Always verify and double check to see that path that's being used. Interesting. So what does that mean? What does that mean, folks, if you have this device routing to the internet and you're using a first hop redundancy protocol like HSRP or VRRP? Right, DSW2 is not routing right now. That is correct. It's not routing. So should we do a show IP route? I got a routing table, and it looks like I can get there. All right, so it's not a routing issue. I have a routing entry. Good, so Greg says, you got to check HSRP here, Raymond. All right. So Greg is saying that even though the diagram says HSRP is active, it might not be. This is what I want under normal conditions. HSRP to be active here, the active forwarder, the active default gateway. But right now it appears, since this one is routing for me, it's more than likely the active forwarder. So we'll type in show standby for VLAN 30 in this example. And we'll see here that we own that MAC address, so that's good. And it says that we are standby. All right, so DSW2 standby, that's why it's forwarding it to DSW1 in this scenario. So that means DSW2 is also my root bridge. You see how these technologies affect each other, folks? So DSW2 is my root bridge, which is what I want. As I said, remember, I want the traffic to go this way. DSW2 is the root bridge. It should be the active forwarder, but it doesn't look like it is. So we'll check DSW1, correct? Yep, let's do that. Show standby, VLAN 30. Oh, wait a second. I'm active. You're standby. So, folks, what determines if you're active and if you're standby? Right? What determines that? It is going to be a numerical value, and we call it, yes, priority. Exactly. Priority. So priority is 110 on DSW2, and DSW1 has a priority of 100. Folks, with HSRP, is higher or lower better? Is higher or lower better? It's higher. It's higher, folks. That's right. Higher is better. So if I want DSW2 to be the active device, it has to have the higher priority. So DSW1 is 100. DSW2 is 110. It is higher. It is higher. So, exactly. Jeff's like, Raymond, over here. Preempt. Preempt. Exactly. Jeff, excellent job. Well done. Notice preemption is disabled on DSW2. It's disabled on DSW1 as well. What does preemption do, folks? Preemption is a feature of HSRP that tells the device, if you have the higher priority, you become active. That's right. If you have the higher priority, you become active. So we're going to turn that on. So for interface VLAN 30, so this is on our SVI. This is where we've configured HSRP on our SVIs. So interface VLAN 30, standby for group 30 is going to be preemption turned on now. And so we'll exit out of here. We'll check this out. And preemption is now enabled. And notice, I'm active now. I'm active. So because I'm active now, we are not going to be forwarding it across that link anymore. We are going to route it ourselves. That's what we're going to be doing. So if we analyze the MAC address table now, show MAC address table, dynamic, earlier on this router, multi-layer switch, when we looked at our MAC address table, we saw we were forwarding AC1E where? AC1E to DSW1. That's what we saw. But now I want you to notice it's not in here. What? Where did it go? Let me show you where it went. Whenever you create an SVI, your multi-layer switch puts the MAC address in the MAC address table as a static entry, so that device knows that it has to process the frame and not forward it. So now this router knows when it gets it, it processes it and forwards it by routing. And there you go, folks. That is it. We are officially out of our escape rooms. Thank you so much, everyone, for hanging out with me here today. If you are unfamiliar with who we are, we're StormWind Studios, and we are here to assist you with all of your learning needs. So take a look at what we have to offer, folks. So that way there, you can take advantage of every single video that we have created, whether it's security related, whether it's Cisco related, PMP, ITIL, A+, Network Plus, Microsoft, Linux, Python, you name it, folks. Don't be shy. We want to hear from you. We want to help you. We want to be part of your educational journey. So right here in the chat area, as well as on the screen, we have provided you with a link to partners.stormwind.com CCNA webinar. And this will take you to this page. So let me show you the page. This page right here where you can get $250 off any all access package. And there's a catch though. This coupon code expires. So don't delay, folks. Really take this opportunity to get the education and training that you need so you can make a difference for your organization, but more importantly, you can make a difference for yourself. The more knowledge you have, the more valuable you are going to become to your organization, to yourself. And as a result of that, there's going to be great things for you down the road. So we'd love to hear from you. Check out that link or reach out to Mike Fajan, folks. Thank you so much for taking some time here on Friday to hang out with us during the webinar. If you have any questions, please feel free to chat them in. But until next time, folks, keep up the amazing work, and we look forward to seeing you in a future session with us here at StormWind Studios. So take care, everyone, and bye for now.